So like I was saying, today we're going to be graphing radical equations. Now, just like the rest of the year, we have a transformation function that includes a, b, h, and k that tell us how the parent function is transformed to create a new graph. A, b, h, and k still remain the exact same as they've been the entire year. What does a do to our graph? Yes, it is our vertical stretch or compress. Now, if a is bigger than 1, what is that? That is a vertical stretch. Meaning, on my vertical, which is my up and down, I'm stretching, making the graph taller. If a is less than 1, what is that now?
Vertically compressed.
That is a vertical compression. Meaning, on my vertical, I'm compressing, making my graph fatter. And if you want to write those words down to keep these straight in your head, go for it. So vertical stretch means the graph gets skinny and tall. And vertically compressed means the graph gets short and fat. Now, why am I putting absolute value symbols around my A?
Oh, because if it's negative, it's a reflection?
Yes, the negative does something different. Having a negative A does what? It vertically reflects it. Meaning it reflects over which axis? The x-axis. It vertically reflects over the x-axis. Now what about B? What does B do? So just now we talked about A. Now we're talking about B. Instead of it being a vertical stretch and compression, what is it? Horizontal. And everything inside of our function is always backwards. So, what does B do if it's greater than 1? It's a horizontal. It's backwards from A. If A is bigger than 1, it's a vertical stretch. We know that B is backwards from A. So if B is bigger than 1, it's a horizontal compression. Yes. And if B is less than 1, it's a horizontal stretch. So if on my horizontal, which is my x-axis, if I'm compressing that, what does my graph become? If I'm on my horizontal, everyone look at my arms. If I'm compressing, what happens to the graph? It gets taller. So even though it's a horizontal compression, it still looks the same as a vertical stretch. It gets skinny and tall. What about a horizontal stretch? So on my horizontal, everybody look at my arms again. On my horizontal, this time I'm stretching. What does the graph become?
Thin and wide.
Wide and short. Short and fat, I call it. And then if B is negative, what does that do? It horizontally reflects, yes, meaning we reflect over the y-axis. what about H? What does H do to our graph?
Translates.
It is a translation. Good. So both H and K are translations. So between H and K, I'm going to write translation. H, is that a horizontal or a vertical translation?
Horizontal.
Yes. Everything inside of your function is always going to be horizontal. Everything outside of our function, everything outside of the root is going to be vertical. So that means H is horizontal.
And K is vertical.
And K is vertical.
H is backwards.
And H, because it's inside, is backwards, yes. So if H is negative, where does it go? It goes to the right. And if H is positive, where does it go? Left. If K is negative, where does it go?
Down.
Down. And if K is positive, where does it go? Up. Wonderful. Is any of this new to you? Hopefully not. It should not be. We're on our 10th unit. I think we're on like our 6th function. So you've done this. This is now our 6th time. Hopefully not. Okay, so now we're going to be graphing. We're going to be using these transformations to remember how to graph. Now, what's graphed on your paper is the what of the radical functions? The parent function. Yes, this is our parent function. The blue line is our parent function. It always starts, so I'm going to say this, sir. I'm going to write blue line is parent function. Where does the parent function start? Always starts at the origin, 0, 0. Because it's the parent function, where is the next perfect point?
1, 1.
Yes, next perfect point is up 1 over 1. Up 1, right 1. That's how you know it's the parent function. It starts on the origin, and the next perfect point is up 1 over 1. Now, we're being asked to graph on this same graph 3 different equations, A, B, and C. Actually, we're not going to, that's right, I'm not going to do C. It's just a little bit too tricky for us. Now, A. We need to graph y equals negative square root of x plus 4 and a minus 1. Looking at this equation, where is our starting point? What determines our starting point?
H and K.
The H and K. What is our H value here? Technically, remember it's backwards, so technically H is a negative 4. And what is our K?
Negative 1.
So what's our starting point?
Negative 4,
Negative 4, negative 1. We also could have known this because what are our transformations for this function, for this equation?
Vertically reflected.
It's vertically reflected, meaning over the x-axis. And is translated left 4 and down 1. As long as you list them together, the H and K transformations, you only need to write translated once. So translated left 4, down 1. That's how much it's translated. So let's go ahead and graph it, and then we'll discuss our domain and range, okay? The first thing we're going to do is we're going to reflect it, okay? So in our heads, the first thing you're going to do is take this line, this parent function, and it's now upside down, over the x-axis. All right? Then, we're going to move our starting point. So we're no longer at 0, 0. Instead, we're moving left 4, 1, 2, 3, 4, and down 1. So that's our starting point right there. From there, where do I graph my next point? Because it is reflected now. Where's my next perfect point? Instead of going up 1 over 1, like the normal parent function, it's been reflected, so where do I go? Down 1 over 1. Good. And then I just do my swoop. If you want to graph more points, you can. The next point would be over 4, down 2. But 2 is about all I need. 2 perfect points. So, what is the domain in set notation? Squiggly, yes, squiggly bracket. X such that is it all of the x values bigger than this -4? Or is it all the x values less than the -4? Bigger than. And are we including -4? Yeah. Yes, we are. So we write a greater than symbol and what? An equal to symbol below, so a line below, -4. And squiggly. What about our range? So range is y, so y such that y. And then are all of our y values bigger than or less than that y value of -1? Less than. They're all lower than -1. So over here I write less than -1. Is anyone noticing anything? Gonna call me on something?
You have to put the equals.
You have to put the equal to sign below. Liz doesn't even know what I wrote, and she knows what mistake I made. You guys. You have to put the equal to symbol below the less than. Okay. So now, we're going to graph y equals 1/2 square root of x plus 3. So our starting point is 0, 3 because we don't have an h and our k is 3. Where's our next perfect? Here. It is vertically compressed, so that's one of our transformations. And what? Just to finish it up, what was our next transformation? Our only other transformation? Translated up 3. So where's our next perfect point? On your table, we're looking for 2 whole numbers for x and y. Where's the next perfect point? I didn't graph this. I didn't put it in my calculator. You guys got to help me. Where's my next perfect point? Where? 4 what? 4, 4. 4, 1, 2, 3, 4. Perfect. See how it's vertically compressed? It's much shorter. Okay, so what is our domain in interval notation? So I in my head think of domain and range always as intervals because I like to ask myself, what is our least x value? What's our lowest x value? For the green line that I graphed, the one we just graphed. What's our lowest x value? 0. Is it equal to 0? Do I actually have a point on 0? Yes, you do. So what do you put next to the 0? A parenthesis? No. That's a bracket. You put a bracket when it's equal to a bracket. And what is our greatest x value? What do you go up to? Infinity. What do I put next to infinity? A parenthesis, because you can never be equal to infinity. What about range? What's our lowest y value? 3. Is it equal to 3? Yes, it is. So I put a bracket. And what's our greatest y value? Infinity. And what do I put next to infinity? Parenthesis, because we cannot equal infinity. Any questions on these two graphs? Okay. So take a look. How can you determine the domain and range without graphing? On a radical, what value determines our domain? The what? The h value, right? Look, we don't have an h value here, it's 0. What was in our domain? That h value is 0. What was in our range? The h value? The k value. The k value. So, looking at our equation, the h will determine the domain and the k will determine the range. Of course, you always have to be careful if it's been reflected. What will change, the h or k value? I'm sorry, not the h or k, the domain or range, if it's been reflected over the x-axis.
Domain.
The range. Instead of it being bigger than the k value, it'll be less than the k value. All right, let's go ahead and we're going to graph cube root functions. Well, let me hold up a second. This is our parent function. Notice it is centered where? It is centered on 0, 0. So the parent function centered on origin. Does anyone remember what that center point is called? On a cube root and also a cubic. I know you guys learned cubics this year. What was that center point called? Starts with an I. Inflection point. It's literally on your paper. Right here. Inflection point. It's kind of where it squiggles, I like to call it. It squiggles in the center. And from there, from our inflection point, the next perfect point on our parent function is where? Up 1 over 1. And also because this is a cube root, we also go the other direction from our inflection point, down 1, left 1. You're always going to have those 2 perfect points surrounding your inflection point. I want you guys to try to do, I'll have you try to do A, B, and C. I want you to graph A, B, and C. You have your calculators. You know how to find domain and range. You know how to find transformations. Go ahead and do A, B, and C. All right, guys. What for this one was your inflection point? Yes, -2, 0. And that makes sense because our H is -2 and we do not have a K. So our inflection point is -2, 0. So that means on my graph, I'm going to graph a point at -2, 0. What other perfect points did you find on your graph? I need at least 2 more for a cube root. I really wish I had my calculator downloaded on this. I should do that. What 2 other perfect points do we have?
I just uploaded them this morning, so maybe they're not. What about?
So the next perfect point being way off our graph means we can't graph it. But to approximate this, I could graph that point 6, -0.5. You see that on your table? How there's a perfect point, well, not a perfect point, but a half point at 6, -0.5. Where else is there a half point? Where else is there a half point? On our table. Holy. Do you guys not understand what I mean by half point? Six -0.5. Yeah, that's the one that I graphed. But then there's another one going the other way. -6? I don't think so. So -3 has 0.25. That's a quarter point. I'm looking for a half point. -10. There it is. -10.5. Whew. Okay. So there's our graph. Now, what were the transformations we had here? What's happened to this? Looking at our values. It's vertically reflected because of this negative, right? That's a vertical reflection. What else has happened? It's vertically compressed by how much? What else has happened? One last thing. Translated left to. What is our domain? What's our lowest x value? -infinity. And what's our max x value? X value. It goes all the way up to what? Infinity. So what is our domain? All real numbers. And in set notation, we write all real numbers by saying X is an element of all real numbers. X, epsilon, all real numbers. And what about our range? What's our lowest y value? Does it keep going down forever? Yeah. Does it keep going up forever? Yeah. So what's our range? All real numbers. Squiggly y is an element of all real numbers. All cube roots will always have a domain and range of all real numbers. So immediately, B and C, you can fill in all real numbers. Now it's interval notation, so it's negative infinity to infinity. Negative infinity to infinity. Negative infinity to infinity. Here. Okay, you guys keep going.